Hello, everyone, and thank you for joining us. My name is Vincent Martinez. I am the President and Chief Operating Officer for Architecture 2030, and I'll be acting as moderator. Welcome to the second session of a three-part series called Mass Timber Construction, an economic study of supply, best use, and implementation in three North American regions. Today, we will talk about the series that unveils a macroeconomic study of the buildings with mass timber in those three U.S. regions: the Upper Midwest, Rocky Mountain, Colorado, the Southeast. Three companies that you'll be hearing from today: SCB Architects, LeMessurier, and Turner Construction Company collaborated for 2 years under a U.S. Forest Service Wood Innovation Grant to redesign buildings in Minneapolis, Denver, and Atlanta, revealing cost differences, schedule savings, global warming potential savings, and design considerations of each. The building studies were completed by a comprehensive mapping of the U.S. mass timber supply chain and its potential on forests and impact. That was actually part of session 1, which the recording will be posted to the Olifant website tomorrow, and we'll put a link in for that in the chat. Olifant is the sponsor of the grant, which a company helped to launch the Mass Timber Accelerator grant programs for developers in the cities of Boston, New York, and Atlanta. And the studies were also conducted in consultation with many regional partners, including members of AIA Minnesota, AIA Colorado, and AIA Georgia. Architecture 2030 is very pleased to host this webinar series where the authors of the study will present their findings and engage in an informative dialogue. As I mentioned, this is the second session in the three-part series. The first session was held 2 weeks ago with myself as moderator and the founder of Olifant, Nicole St. Clair. That session was recorded and will be posted on olifant.org tomorrow, along with the webinar slides from that session. It was really informative, so I encourage you to join and listen in. The second session that we'll have today is titled Mass Timber, Carbon Cost, and Constructability. As I mentioned, we will be hearing from an architecture firm, SCB Architects, the engineering firm LeMessurier, and the builder Turner Construction Company about the results of their mass timber analysis for 3 multifamily buildings in these different regions, including comparative costs, construction conditions, and global warming potential. They'll highlight the sweet spot for zoning and code adoption, where mass timber can be used for a number of affordable housing units and maximize their global warming potential with minimized cost implications. This is the first time that national market leaders will share their analysis of potential benefits and design and construction of mass timber. You'll hear more from our panelists, but the project represents 3 building types described as type 4 code for mass timber. Type 4A is used in Minneapolis, 4B in Denver, and type 4C in Atlanta. They'll correct me if I got any of that wrong. With that, I'd like to pass it over to Ben Harrison from SCB to get our presentation started from the day. I'll just note that this session is being recorded so that it can be shared on the Olifant website. The presentation slides will also be shared through that, as well as the next session, which we'll talk about at the end. And then just note that we will have limited time for Q&A at the end of the webinar, but please do include them in the Q&A panel. My colleague Billy Craig is funneling that, and we'll push it up to me during the Q&A part of the session at the end. So with that, I'll turn it over to Ben. Thank you, Ben. Welcome.
Great. Vincent, thank you so much for that introduction. I'm Ben Harrison with SCB.
Hi, I'm Suzanne Robinson. I am the Director of Sustainability at LeMessurier and also a structural engineer.
Dave Robb from Turner Construction, one of the project pre-construction managers.
Great. So Vincent kind of teed up what we've been working on for the past 2 years, and we're really excited to share some of the work, some of the carbon savings, cost schedule, everything. We can kind of dive into that. But first, we wanted to thank all of the organizations, suppliers, AIA chapters, and local architecture and engineering firms that we met with along the way to kind of help us in this process. So the process started off with us actually meeting with all of those local AIA chapters to determine a program type and rough construction size that would fit within their context and something that they may be looking for more of. Not surprisingly, the construction type that all 3 selected was housing. Definitely have a housing crisis across the country, and each one of these regions was looking for a more kind of carbon reduction and cost reduction way to kind of get more beds. Each region also was looking for a very different scale in building. So Minneapolis was looking for kind of the smallest size building. Denver was looking for kind of that mid-tier, and Atlanta was really looking for that density in those tall buildings. Once we had the kind of program and general size of the building down, we went back and we selected 3 buildings that had previously been constructed so that we could provide an apples to apples comparison between a markedly viable building that was built in conventional construction with how that could be redesigned in timber and what the result would be, both from carbon, cost, and schedule. Those are the kind of 3 big things that we looked at. So Minneapolis is a 6-story building. This was built in just conventional stud framing. This was a 5/1 structure that we really see kind of across the country. Both Denver and Atlanta at 12 stories and 21 stories were high-rise type 1A concrete construction. We'll get into a little bit more of the construction types that we transitioned these 3 buildings into. But one of the things that from the onset of this study worked out really nicely is that each one of these regions kind of fell neatly into the new tall mass timber constructions that are outlined in IBC 21 and 24. So it was very important to us from early on that we wanted these studies to be not only markedly viable, but out of the box code compliant. These don't seek for any variances from the applicable codes in their areas, which I think is a really important thing to note because mass timber has been around for quite some time, but under the previous IBC, there were tended to be a lot of variances required in order to really maximize the potential of the material. This study looks at what those codes do to allow for this to really be a third viable option. When we're building big buildings, we think concrete, we think steel. Well, timber can be that third option and really kind of diversify the building structure that we see in the market. So again, Minneapolis was type 4C. As a quick code review, I'm not going to dive into all the nitty gritty, but for the most part, type 4C is 9 stories and below. And the big thing to note is that this allows for 100% exposed mass timber. You don't need to provide any additional fireproofing to the mass timber. Denver, it's important to note, is under IBC 2024. IBC 2024 has slight modifications to the tall mass timber provisions, which allow for 100% of the ceiling to be unprotected timber and 40% of the walls to be unprotected. This is slightly different from what is required in IBC 2021, but it's important to note that that type 4B, which is 12 stories and below, is kind of the middle ground. Some timber has to be concealed, some timber can be exposed. And then in Atlanta type 4A, this is looking at your tallest construction, and this would require all of the timber to have some level of protection around it, drywall, fire protection, something. That usually means that most of the timber is not exposed, and this is really used more of a structural material and less as kind of a visual item. As was mentioned, the country is slowly adopting these codes. This is a current map as of February of this year that looks at where these tall mass timber provisions have been adopted. All of the gray regions are still using codes prior to IBC 21, and then the blue is a myriad of different IBC 21 and 24. For all of the local Massachusetts people, I'm excited to say that we recently, as of a couple weeks ago, adopted our 10th edition, which is based off of IBC 21 and can allow for the tall mass timber. So diving into the LCAs that we did on these structures, this was from a macro level what we looked at for Atlanta. The base building was a concrete type 1A construction, a podium style building with several levels of parking above grade, and then the rest of the residents above that. The mass timber portion looks at keeping the concrete podium simply because parking and concrete tend to work much better. And it also allowed us to build slightly taller with the mass timber on top of that podium level. The mass timber itself is a post and beam with CLT structure. And what we see from a high level is about a 16% reduction in total global warming potential. What's interesting here, and we can kind of dive into this on the next slide, is that it is not necessarily a reduction in every category. And I think I'll transition to the next slide here. And we can see that on those top two categories in fire protection, we really see a growth in the amount of carbon required. This is because Atlanta is that type 4A that requires so much fire protection around the members itself. Concrete has that kind of inherently built within it. But now I'll turn it over to Suzanne to talk a little bit more about these different categories that we analyzed for the global warming potential.
Absolutely. And just to build on that, our base case was concrete columns with 12-inch post-tension concrete slab on a concrete podium. We did go to a post and beam one-way system of glue-lam columns and beams with a 5-ply. It's good to note that the beams in the Atlanta case are perpendicular to the exterior. We'll see a slight difference in the variety on Denver. We do see in this chart in our study, the greatest reduction in carbon was due to the floor structure. You do see an addition to materials. The GWP has addition of acoustic underlayment and gypcrete topping that's needed to meet the acoustic requirements. As Ben had mentioned, concrete inherently provides a higher acoustic protection. But even so, with CLT floors, we have that carbon storage, that reduction in body carbon. So overall, the acoustic assembly is still a much lower reduction than our concrete floor in the base case system. If you're looking at the other categories, the parking, the foundations, the exterior are all relatively similar. They changed a little bit, but not drastically. And although the carbon for the structures goes down, there is that increase in the architectural carbon, mainly due to the top two rows that we can see of the additional fire protection that's needed to meet the code requirements for both the vertical and the horizontal elements.
And Suzanne, one other thing that I'll mention that I forgot to is that with Atlanta, one thing that we do see is a minor increase in the exterior enclosure, and that is largely due to the fact that the floor-to-floor actually had to change in Atlanta in order to keep the same level of exposed ceilings from the base case. So we had to grow each floor by about 4 inches. It's important to note that we tried to keep everything exactly the same with the exception of the structure, and in cases where it wouldn't be feasible to build in that certain way.
Good point. Yeah, MEP coordination, always a challenge in there. So overall, structural reduction reduced by 29%. For structural, we're including the foundations, the lateral system, the gravity system, as well as that acoustical requirements of the floor that I mentioned before. However, note that the architectural embodied carbon increases. And again, this is mainly due to the fire protection. However, note that the architectural carbon changes are relatively small compared to the overall structural. So if you look at the donut in there, architectural is about 1/3. Structure is about 2/3 of the carbon. And it's worth noting that of the structural component, over half of the embodied carbon of the structure is attributed to the 8 levels of stacked concrete parking that we have. So about 54% of structures carbon is associated with the parking.
When we move on to the Denver case study, this is transitioning to the type 4B construction type. This is going from the base building, which was cast in place concrete, type 1A construction throughout, parking podium with cast in place columns and floors above that, to a mass timber building that is post and beam with the parking podium below and glue lamps and CLT up above. We do see a greater reduction than with the Atlanta case. We're bringing in about 22% reduction in overall carbon. And this is largely due to the fact that Denver has pre-adopted the tall mass timber requirements of IBC 24, which allows for greater percentage of the timber to be exposed. That greater exposed timber results in carbon savings, cost savings, schedule savings. It's a huge kind of reduction across many levels. So when we start to look at the individual sections, you'll see that there's a very minor increase in that fire protection because, again, we're able to keep most of that timber exposed.
Yeah. So with Denver, again, similar to Atlanta, we went from a concrete column with 8.5-inch post-tension concrete slab on that concrete podium to a post and beam, one-way glulam column and beam system with the 5-ply floor. In this case, the beams are running parallel to the exterior. So we're able to really maximize the view from the units. So there's a marketability aspect for that. Again, the floors, we're seeing the largest reduction. It's wonderful kind of going through and digging through all this analysis that was one of the things that came out through all of these studies and what we're seeing consistently through other projects as well too. Even so, we're having to add that gypcrete topping and that acoustic underlayment, but overall, we're still seeing a reduction, both to the reduction in carbon as well as the carbon storage that the CLT floors provide. Again, the foundations, the parking, the exterior, relatively minor adjustments there in the embodied carbon. And then again, I'm just going to note it again. I know Ben mentioned it, but seeing that fire protection along the top is almost neutral. So it's now falling into the categories of the parking and foundations and stuff. And again, this is due to Denver's adoption of that 2024 IBC provision for the Type 4B buildings that provide 2 options for fire protection. So in addition to the gyp, we can also now design with char. And by designing the structure to have char, we're allowing more mass timber to be exposed, which overall reduces the amount of additional materials we need, which in turn reduces the embodied carbon. And then I think I'll go to the next slide. So the structural reduction is 31%. Again, this includes the foundations, the lateral, the gravity systems, and the additional acoustic requirements for the floor. And then there's only a nominal increase for architecture, 5%, compared to our 31% for back in Atlanta. And again, this is due to that alternative method of fire protection as outlined in code that uses less materials with designing with char. Again, structural is about 2/3 of the total carbon picture. And of that, it's 44% of the parking is the structural component of embodied carbon. And that's that 4 levels of concrete parking, which is more spread out in this type of a structure, a mid-rise structure.
When looking at the Minneapolis project, we see the greatest carbon reduction with 42%. We transitioned from a stick-built construction with a 1-story concrete podium to full mass timber on the mass timber case study. This is notable because we're able to go from a 5/1 kind of building with a 3-hour fire separation between them to one singular structure. Just makes things a lot easier, and we see a great kind of reduction. The other thing to note in here is that because the floor plate of a timber framed building is genuinely pretty tall, we actually noticed a floor-to-floor reduction in Minneapolis. So we lost about 6 inches per floor, which is important because that shrunk the exterior. It allows you to fit into different zoning categories. It's kind of a win all across the board. When we start to look at the kind of individual categories, we now start to see a reduction in fire protection. That stick-built system, and especially the floor system, does require a fairly large buildup in order to maintain that rated separation between levels. With the timber, we're able to kind of achieve that through char and topping in a slightly different way. So we're starting to see the opposite of what we've seen in the Denver and Atlanta buildings. We're actually seeing a reduction in the fire protection.
Yes, and just to reiterate, so this is a original base case was concrete columns with 12-inch post-tension concrete slab with light framed wood for the residential units. And then we switched over to load-bearing CLT walls with the 5-ply CLT floors. So again, floor reduction, even with the stick build requiring similar acoustic treatment, because again, it's got that need due to the timber aspect of it. The CLT, the reduction that we're seeing is due to that carbon storage that CLT panels provide. The other thing to note here too is the fire protection was reduced twofold. So the structure was initially a concrete podium with the stick build above, but now that we're switching over to completely mass timber for the entire structure, we can remove that 3-hour fire protection between the two building types. Also, for the stick build, you can't expose the joist, whereas with the mass timber, we can have the CLT exposed. So again, that kind of has that double benefit from a fire protection point of view. Of note for Minneapolis, for this project did not have parking located on site. That was off-site. Foundations are relatively similar, but more importantly, the foundations are the only structural concrete in the structure now. Working on all these projects that we see in our day-to-day life, we're always constantly trying to reduce the amount of concrete and trying to optimize that material. Now we've been able to remove the concrete of the podium, and we've also been able to remove the concrete of the lateral system. So we replaced the concrete podium so that it's all mass timber. And then we're also able to address our lateral needs for the structure with the CLT shear walls. So with this project, we're seeing an overall 46% reduction for the structural and a 38% reduction for the architectural. So I think that's a nice win where we're starting to see both reductions on architectural and structural components. So on the next slide, when we're looking at the analysis overall, first I do want to just take a moment and just mention that throughout the study, we did consult with our partners, which included the local AIA chapters and also our local structural engineers. I do want to do a shout out to our fellow structural engineers. So we worked with Meyer, Borgman, and Johnson for the Minneapolis project, KLNA for our Denver project, and Equilibrium Engineers for our Atlanta project. We also worked with Carbon Leadership Forum, CLF, and Woodworks, as well as Turner's design team for the analysis review and design recommendations. We did use Tally to develop our LCA, and the scope of the building analyzed included the structural elements and the architectural elements that would change between the two cases. So mainly it was the envelope as well as the fire protection components. One thing of note is we've kind of mentioned it a little bit, but I do want to kind of bring attention to this. These were all existing buildings that are currently being built or have already been built. These are from a portfolio of projects within SCB's portfolio. We are specifically looking not to have a theoretical project, but to really look at buildings that are market viable. How can we actually take these market viable buildings and turn them into mass timber? We did not incorporate all the design optimization you would normally see on a project that's pursuing mass timber, especially if we started the project with the intent of using mass timber, because we really wanted to try to be comparing as much as we could apples to apples between the two cases and not skewing the results. So for example, we didn't rework the grids, but only adjusted them where we absolutely needed to make the mass timber fit into the existing grid system that we were working with. So that being overall, the results aligned with pretty much what we expected. So for the taller you go, the more carbon per square foot you're going to see. Savings aren't as flashy as maybe some other studies that you'll see, but we really wanted to look at the whole structure and really try to be as much of an apples to apples. That being said, although they're not flashy, it's still substantial. So the purpose again was looking at market viable buildings that are being built today, and not just separating out certain architectural or structural elements. We were really focusing on the functional equivalency. So for example, often when you're comparing structural concrete to structural mass timber, you're leaving out that acoustical components that you really need for that functional equivalency. You're not going to be able to build the structure without those additional acoustic layers. One of the things that I think struck me is, parking, you always kind of know is, a big piece of the pie, but didn't really see how big a piece of the carbon pie it is on our projects until we were looking at this. Our cars really do have a much bigger carbon footprint than I think we realize. If we exclude the parking or even potentially reduce it, we would see a much larger, we would see a larger percent reduction going from a concrete structure to the mass timber option. So if we were just looking at the superstructure. And then I think the last thing I want to leave folks on is, you look at this, you see the 42% reduction in Minneapolis overall, 22% for Denver, and 16% for Atlanta. But don't be fooled by the smaller percentages because the potential to save is substantially more for the larger building. It's a more powerful percentage point. So for instance, the amount of carbon that Denver saves is 3 times the amount of carbon that Minneapolis saved, going from a concrete to a mass timber structure. So again, I think as we wrap up this point and turn it over to Dave to talk about cost, I think it's just fundamentally, as structural engineers, we're really exciting to just have a third building material to work with. It really opens up a lot of possibilities and opportunities to innovate.
Thanks, Suzanne. You teed it up nicely for me. Hello, everyone. Again, I'm Dave Robb from Turner Construction. And, as part of my role as an estimator, I love to, get into the nitty-gritty of the drawings and sort of develop this, detailed estimate. And so we were trying to think for this effort, at the beginning of this grant, when we were together, it's like, well, how are we going to do this? It's easy for things to get lost in a detailed estimate that you're trying to decipher what's changing. And that was really the goal, was not to just deliver a 100-page slide on all the detail, but rather sort of how can we pull out the highlights from that and really tell the story of what changes, when we wanted to switch from a cast in place or stick built to a mass timber structure, and understand, specifically what the major scope changes would be, and then the implications of the cost from those scope changes. So that was my main goal as we approached this. And for a little bit of context of the cost study that I completed was, we were working with sort of this conceptual schematic level detail. So, some assumptions were made where necessary, but for the most part, I was able to quantify, what was on the drawings. And we did rely on a mix between some sub-market feedback and then some, historical relevant data to put it all together. And so I'll sort of quickly explain, what the numbers are that you're going to see on the next few slides as we go from Atlanta to Minneapolis. And then I'll sort of wrap it all up at the end with sort of my conclusion thoughts. So on this page on Atlanta, what you're seeing in the top right corner is the cost per square foot delta that we have between the base case and the mass timber case. And that, what the numbers that are driving behind that are are from what I was saying and sort of what Suzanne was touching on at the end there was sort of like the functional equivalent. So, depending on where we were, we're switching structure. What is the code telling us to do? We're going to need some acoustical, floor assemblies that we might not need. So, and then, how is the schedule playing into that overall? So those are sort of the high level, cost factors that we were evaluating to get to that number you're seeing. And then below in parentheses is the percentage delta on the overall project volume cost. So just to, think about it two ways. One is sort of the cost per square foot at a minimum, what's going to need to change. And then how does that look on your overall project volume with that percentage? So if you can hit it one more time, Ben, you'll sort of see on either side what's trickling in some of these, cost factors that we saw. Atlanta, as you heard, being, type 4A, the most stringent for, fire protection. You have sort of those 3 layers of drywall on all of your elements, which is contributing to one of the cost factors. And then additionally, that floor buildup is something that you don't need in a cast in place building, but in the mass timber building, you're going to want. However, one thing that was you'll see is this building being as repetitive as it is. We sort of ran a simulation for schedules for cast in place versus mass timber. And mass timber with this prefabrication, leading into that, you can really go fast, and it shows in this case where we're somewhere in the realm of 3 months. And thinking about that from your critical path schedule, got to get your structure up. That's significant. So we tried to give back, from the general contractor's point of view, some savings on your indirects. If we go to the next slide, I'll get a little bit into Denver. Same exact layout here. We did a little bit better with type 4B, and I think if you keep going, Ben, some of the contributing factors here, you'll see are what we talked about in Denver adopting the 2024 type 4B, where we have less fire protection on the underside of our CLT. So that was helping us considerably. I think also some of the market feedback that I got from some of the mass timber fabricators said that there's some efficiencies in this building that made it the most cost competitive of the 3 options. And then additionally, you'll see here we have a significant schedule savings. Just again, a repetitive building that stacks up. It's not quite as tall, but it's sprawling, so you have that. And then lastly, another item you see there, on Denver was some of the savings you see for the interior finishes with the ability to leave your ceiling exposed. Okay, and then if we jump over to Minneapolis, again, we saw roughly a $16 per square foot difference here, 3% overall on the project volume. And if you hit it one more time, you'll see sort of the differences here, the contributing cost factors. On the previous 2 at Atlanta and Denver, we weren't able to, or the part of the study, the foundation was not part of it, part of the scope, the cost scope. But on the case with Minneapolis, we were able to get to evaluate the foundations, and we found that there was a slight reduction in the overall cubic yards of concrete, which was one of the cost savings. And then additionally, what we talked about before, type 4C, there's no fire protection in this scenario, or I should say the fire protection is in the mass timber with the char rating. So it really allows you to sort of lean into the aesthetic of the mass timber, and and there's a good potential there for interior finish savings compared to your base case. I will say that the mass timber structure might have been a little bit more than the stick built, but I think in my closing thoughts, I'll touch on that and ways to potentially mitigate that in the future. But okay, I think if we what I'd like to do now is just I just threw a ton of numbers at you, which is not what I love to do, and I don't want you to sort of leave there. We're trying to interpret all those numbers, but mostly I want to close with like 4 main takeaways that I hope you consider after leaving today. I think the first thing that we've learned, and I hope is a good takeaway today, is understanding, the type 4 code now with A, B, and C, and how it's going to affect you, and making sure you're trying to get your working to fit your project in the right code. Knowing that the fire protection on your elements is going to have a cost impact. So that was, the higher you go, obviously, the more you need to cover, and the more of the additional layers of coverage you're going to need. And then the second part of that is just the acoustical consideration. Again, we're talking about functional equivalency. And if you want the CLT is going to need a little bit of help from an acoustical mat and some sort of a gypcrete or concrete topping on top of that, in order to get the acoustical ratings that we're traditionally seeing in these buildings, residential buildings. So the second part I hope you consider is, for our case, as Ben mentioned earlier, this is with apples to apples comparison for the sake of our study. And it's what we're seeing here for cost is really just the tip of the iceberg. And I say tip of the iceberg because I felt like, since we were doing the functional equivalency and we were so apples to apples, I feel like there was some elements that might have been hurting us cost-wise in terms of advocating for mass timber. And Ben mentioned it, sometimes we had to grow the building a little bit. And sometimes we were counting for some transfer structures in order to accommodate the mass timber grid. However, I feel like even with all those built in, we are still getting within 3% of an overall project volume on 2 of those cases at a schematic level, which I think is totally viable, knowing that there's room for improvement as you go through design. And as I say, the additional sort of cost savings I think you would pursue if you were to take this from our theoretical grant here to a next level is, taking the design that you have and putting it on the street and competitively bidding this. I think you'd get a lot of attraction from the mass timber manufacturing world, and who would also come to the table with some ideas to optimize the design and potentially provide you some additional, inherent savings in the project. So I've certainly have seen that in real world in my work. So I think it's very legitimate. Okay, thirdly, the sort of maintaining this holistic approach. You might have heard the holistic approach with timber before in the cost study, because there are so many sort of moving pieces that we've outlined today a little bit. But of the holistic approach, I like to think about it in terms of leaning into the prefabrication. And I think with prefabrication, we've demonstrated that you can go fast. Your schedule is definitely going to come back to you. The higher you go, the more it's compounding. And on top of that, you'll see, and I'm sure in other case studies, but it's the labor on site required to install mass timber is far less than what you would need for a cast in place structure. So there's some benefits there of having a reduced on-site labor count. And then I think inherently it's a safer product. Anytime you can prefabricate something, there's less risk on the site. So I think that's hard to quantify in this study, and it's not, but it's important to remember that going forward. Secondly, the holistic approach, I wouldn't lose track of hybrid. We didn't do a hybrid study, but in the case of type 4C, I think there's plenty of examples of, combining cold form or even stick built with a CLT deck in the load bearing wall situation. So I like to just remind people that it's not mass timber all or nothing. I think there's plenty of cases where hybrid makes the perfect sense. And you'll still see, some inherent benefits environmentally as well. I also want to point out in this holistic approach that we were not able to capture, any of the owner side savings from a reduced construction schedule and a reduced construction loan. That's not baked into my numbers. That is something that it would be additional. And I think there's considerations too for how mass timber might alleviate some, job site stressors on the owner and or the general contractor in terms of making your site a little bit more friendly for a sensitive neighborhood with reduced truck traffic, with the pieces becoming, getting picked straight from the truck getting erected into the site. And then noise too, cutting down on noise. As you can imagine, there's far less rebar saws, demo saws that are roaring at 7 a.m. compared to just maybe a couple screw guns. So, and then sort of the last piece on the holistic approach is sort of this forestry and environmental piece. I think if you listened to the first webinar, you saw the forestry side of this. And I think it always really resonated with me once I found, figured it out. The whole purpose of this thing is sort of like we have this incredible renewable resource that is in our backyard, these sort of wood baskets, if you will. And once you start to think about it and you see sort of like the environmental savings and carbon reductions that we can find through tapping into this material, it just makes too much sense. And it's still way too underutilized, but we're making progress by, hopefully with the adoption of more codes and developments of these codes to allow for more exposure of it. And so I think for me, those are sort of the main takeaways. And you can see the summary here. I think there's a lot of benefits into, using it with Minneapolis and Denver and even Atlanta. I think there's ways to do it. It's been done, and I think it's just getting creative and working with your design teams, and, understanding that there's paths forward to leading to a successful project from both cost-wise and environmentally. So, those are sort of my pieces. I want to pass it back to Ben here to close this out.
So we've gone through a lot, right? We've gone through all of the carbon savings. We've gone through some of the schedule and cost savings, and we wanted to leave you guys much of what Rob was just doing with kind of like the big takeaways. This is a new building type. This is something that we're now starting to see a lot more of. The codes are starting to change to really adopt it. So where do we see the kind of like sweet spot for this new thing? And I think the reality is that 7 to 12 stories is really that sweet spot for building with mass timber under the current codes. As codes begin to change even further and adopt more tall mass timber provisions, I think we'll start to see that super tall mass timber building that has been constructed, and we've proven that structurally it will work, but right now the codes haven't really caught up to it. So from a type 4C perspective, we see, the biggest strength of this as a replacement for the type 3 over type 1 construction that we see all over the country. It's been a tried and true kind of cost approved way to kind of get a 7-story building done and done quickly. We think mass timber can be an amazing replacement for that will have greater carbon savings, greater schedule savings, and as we've proven in this, very minor cost increases. And to just reiterate something that Dave said, all of these buildings were meant to be an apples to apples comparison. If you start to plan from the get-go with a mass timber module, you'll be beginning to see those savings increase even further. I like to see these savings as kind of like a floor, not necessarily a ceiling. When it comes to type 4B, the biggest takeaway with type 4B is that in IBC 2024, your carbon savings goes through the roof because your protection of mass timber is greatly reduced. We've seen in a lot of locations, municipalities pre-adopting just that small portion of the code, not fully adopting IBC 2024, but just the tall mass timber portions. And that can really unlock a lot of developments with the type 4B. We also see a very substantial savings and the ability to really get a large area. So where type 4C can be great for those smaller buildings, the type 4B can really get you a lot of area with a sustainable construction. And for this study particularly, really make a dent in that housing shortage that we are seeing kind of across the country. We haven't talked too much about type 4A, but it's important to note something that Suzanne said, that Type 4A is really your largest building and your greatest potential to reduce the amount of carbon. So even though this number of a 16% total reduction is kind of the smallest number that we see here, it represents a larger amount of carbon that can offset your operational costs as well as just the general carbon released into the environment. So we hope that you take these key things away, and maybe next time you're like looking at a development or you're working with an owner and they want a 7-story building, you can propose doing it in mass timber. Or if you want a 10 to 12-story building, you can propose doing it in mass timber to really, as again Suzanne has mentioned, provide a third building type that can really become kind of standard place in the market. So before I close, Suzanne, any final thoughts before we go to questions?
Ooh, you put me on the spot here.
I'm so sorry about that.
No, you're good. There's some great questions too in the chat, so definitely look forward to addressing some of those. I think the one thing I might just pop on to talk about real quick here is the thing that attracted us to the grant was not just another LCA redesign, an existing structure kind of comparison. It was part of this larger structure. So we're the second session of a 3-part session. And as Dave had mentioned, there's a lot of work. The reason why we chose the 3 cities was based on the potential for mass timber as an industry with their local forests. And so this is really meant to kind of start seeing how can we use more tools throughout this process. And the third session is talking about how do we help accelerate the adoption of mass timber into our building vernacular and resources through that. One of the things we debated a lot about was what numbers we should be using. Ideally, we'd want to use the mass timber numbers, embodied carbon of the timber that we would be sourcing locally, but those numbers don't exist. So what, again, I think Ben framed this really nicely is we're trying to just show, like, at a bare minimum, this is what you're getting already. And you can maximize it by sourcing timber a lot closer once those industries get built up. You can reduce the cost with just optimizing the design. And then also as the market viability, economy of scale comes into place with mass timber. And overall, it's a net positive for everyone.
Great. Well, what an amazing presentation, and thank you so much. It was so well done in terms of focusing on the carbon comparisons and then the cost comparisons, and to have both of those side by side is really incredible, and to see the different building typologies that you focused on and the benefits of the provisions that you mentioned, Ben, in code of allowing you to expose more of the mass timber. We've got a lot of great questions. We have about 10 minutes left in our scheduled hour. I feel like we definitely could have made this one an hour and a half, given how many great questions we've come through. So I'm going to do a little bit of rapid fire, and we'll if you could keep your answers relatively brief. But we have probably a lot more on the cost side, so we'll get there, but let's knock out the ones on the carbon analysis question. We had a question, particularly Suzanne, this might be for you or for Ben, but you talked about the relative proportion of emissions saved, not necessarily the percentage reductions, but the scale issue. Did you do a carbon per square foot comparison, or even a carbon per occupant, given that we're talking about housing? And does the density, how does that change?
Yeah, so we did see 2 slides earlier. We have the carbon per square foot savings identified. We did take a look at that. We did calculate it. One thing to note, I think this is something that we debate in the carbon world, is it's not the carbon per square foot, it's the total consumption of the structure. So you could have a really efficient structure, but if it's ginormous, you're doing more harm for that. But we did include that, yes.
Ben, did you want to add anything on that?
No, the only thing, and I think Suzanne has brought it up previously, is that like we do have carbon per square foot, but that is greatly skewed because we have parking podiums that are very carbon heavy, and then we have residential floors that are very, reduced amount of carbon. So we did produce that kind of average across the buildings, but it's less telling than I think you might think. One thing that we have done, and we'll hopefully share this on the back end, is just the carbon reduction per residential floor, because we felt that was really more of like indicative of the construction type over the whole building.
Great. Okay, thank you. And then another question on the analysis side on the carbon piece, and I noticed this in your diagrams from the flow charts. The question about how do you account for the wood provisions, particularly biogenic carbon or carbon storage? There were some dialogues, I think, on the flooring that showed a little plus sign. Are you factoring in biogenic carbon or storage as a net positive in your analysis? And if so, what methodologies are you using?
Yes, so we did include biogenic. We're using the default values that are provided in Tally software. We did also discuss this with our larger team of whether we should include with or without biogenic. And in the end came to the conclusion that we include the biogenic. If you look at the industry at large, there's millions of dollars being poured into looking at ways to develop technology around carbon storage. This is more in the concrete world. We have it naturally included already in mass timber. The question always is end of life. But I think we're accelerating so quickly in this industry that we're realizing we're needing to deal with that end of life. And it's going to be a different story. Once the buildings get to end of life, we'll be in a different landscape.
Okay, thank you. And you also mentioned you had a variety of other folks weighing in on the carbon analysis, including your local partners, and KLNA in Denver was also part of this, and we have Alexis from their team. And just Alexis, could you give us a little sense of, are you getting similar numbers and values as you're doing your carbon analysis in LCA, and are you using similar tools like Tally and using those assumptions?
Yeah, can you hear me okay before
We can hear you. Yep.
Okay, great. Yeah, I'm actually so thrilled to see this study and, want to just compliment the team before I keep kind of talking. But yeah, we did a very similar study, whole building LCA, as well as cost and schedule analysis. And we have very similar results. We looked at 4 buildings and kind of in the opposite sense, actually, that we took mass timber buildings and then looked at their functionally equivalent steel and concrete counterparts. And our 4 buildings actually saw almost the same reduction in embodied carbon for the total building. So ours saw a range in 21 to 43%. And so our studies and the studies that you saw today really complement one another. And again, just want to say how excited I am to really see some building LCA studies being published and kind of all the details behind that.
Great. Thank you, Alexis. And hopefully that can be included on the website as well, and some of your work on those analysis. So that's great. Thank you for joining us today.
Yeah, of course. Thanks.
We have a lot of questions on cost for you, Dave. I mean, we could probably spend a whole hour going through them. So I'll just note to everybody, we're probably not going to have time to get through all the questions, but we will hold on to them. And if you also want to reach out directly to Dave, I'm sure he'd be happy to dive into the greater details. You can also look in more information on the slides as we did go through them. I think generally some of the questions are about the scope that you mentioned, Dave, and what was included and what wasn't included in potential savings. Like, for example, you noted the insurance costs for hosting for the owner for shorter construction schedule wasn't included. Could you give a little bit more information about what is in your analysis on the cost and what's not in the scope? Probably more so what's not. We had a lot of questions about insurance, for example.
Yeah, absolutely. I mean, as you said, what's not in there is any owner related costs. So any of the impacts that would be carried by the owner, such as, the financing and or the builder's risk, that is not something or the insurance considerations are not built into my cost study or baked in. So those are 2 sort of big things that are on the owner side, which we unfortunately weren't able to get any, feedback on, but to clarify, those are not in our cost study.
Great. And then we had some specific questions about some of the line items in the cost piece. Particularly, there was a question about Minneapolis saving on foundations in terms of that cost. And I think that was because you eliminated the concrete podium for the first floor. Is that right? And went with a singular system. And so the whole system was lighter. Is that accurate?
Yeah, when we were able to I was able to quantify the existing buildings foundation systems and then LeMessurier and SCB designed a new foundation system. And when comparing the two systems, we had an overall reduction in cubic yardage for concrete. So that realized to some savings that I was showing there.
Great. And then a more general question about the base case for you, Dave, was did you use the actual, or are these projects built yet? And do you have actual costs for construction, or it sounded like it was a mixture of in design and already built?
We were not able to rely on the actual, these were built prior and we didn't have access to those, but we did have, I was able to reach out to my counterparts in these regions and we're able to make sure that our costing was representative of what the current market is for a cast in place or stick built. So
yeah, and we really wanted those prices to be kind of current market value at the same level. The reality is the construction costs from a building that was completed 14 years ago and one that was completed last year, those aren't relevant. Those aren't data points that you can compare. You kind of need to start over again and look where things currently are to make that apples to apples comparison.
If you were to build it the same way now, how would they build
Exactly.
it? Would they price it out versus the alternative? And then we had a number of questions actually about potential savings or increases in cost and potentially carbon from the MEP changes from switching systems. Suzanne, maybe this is a question for you or for Ben.
Yeah, MEP was actually something that we didn't focus on for the purposes of this study. While, of course, there are differences, and something that we did take into consideration was how is general distribution going to happen within these buildings? One of the biggest things when you have kind of a post and beam system is how do you distribute mechanicals and fire protection throughout the building because you have these big beams. So we didn't really take into consideration any cost or carbon savings in the systems changing, but the infrastructure that would be able to accept either kind of vertical distribution ducts and ducts distributing throughout the corridor was baked into those kind of floor to floor height changes and then the member sizing to really kind of make this as viable as possible.
Great, thank you. And we had a general question about what you mean by char layer and being able to save on carbon and the materials with the char. Could you just briefly describe that, Suzanne?
Yes. So as I'd mentioned, there's two methods for fire protection, depending on the code and depending on the size of the structure. You may have both being viable. One was gypcrete, where you just basically build up and encapsulate let's say your structural column to protect it. So that's what gets burnt initially during the fire, and you still have your structural integrity. With char, you're basically doing the same, except you're just building it out with the same material, right? So you're just sizing your column large enough so that the core is still structurally viable and you have kind of extra material that you're allowing to be burnt without compromising the structural integrity.
Thanks, Suzanne. Well, we've got a minute left, and to close it out, I just want to highlight one point that you made, Suzanne, which is that you're looking at as close of a comparison with the way all the parameters in which these were built and designed, or designed particularly as these concrete structures, and the concrete with the stick frame above for the Minneapolis project. But that you didn't take into considerations all of the things you might do differently if you were designing for mass timber and scratch. You mentioned some about spans might have changed. What other factors it would relate to design then that could be asked from you, Suzanne and Ben, of how would you do this differently if it was a mass timber building from scratch? You already knew that. What are the efficiencies you could get through design? And then the question would move to Dave and how that might change some of the cost parameters with this design efficiency. So if each of you could just have 1 minute to talk about that, what you think the highlights would be from designing for mass timber and scratch instead of trying to make it fit into the existing concrete puzzle. So Suzanne, go ahead first.
I'll go first. Thank you. So I think the biggest challenge is education. So I really love seeing so many people reaching out and learning, educating themselves more about mass timber, because you are looking at different kind of parameters that you're working within. And so that really needs to come into play at the beginning. Ben can talk to as you're starting to lay out your program and stuff to kind of understand what are the bay sizes that you're going to want to have for grids. You'll note that in all the projects, we tried to keep it to a 5-ply. And so even though there is mass timber that can be built up to be larger sizes and meet larger spans and heights, to make it cost comparable and actually to be more efficient, both cost and for carbon, we're wanting to kind of maximize it. So you really wanted to keep within that 5-ply, and that really starts with your bay sizes. We have a project that we're currently working on in the office that is mass timber, where we started with mass timber. We had a wonderful dialogue going back and forth with the architect of just refining, hey, where should this column be? Where should that grid be? How can we optimize it? What do I need to work with as an architect? And I think that's one of the things as an architect, you can work with your engineers a little bit more. We love figuring out a problem and we can make anything work. But instead of backing it in with structural steel or concrete, we really want to be doing it together.
Great, thanks, Suzanne. Ben?
Yeah, and to piggyback off of that, I would kind of say unit layout. I mean, I know that many residential firms have kind of, and many developers have kind of prototypical unit layouts. Trying to adopt those after they've already been designed and defined, and your 10-foot bedroom, your 10-foot living room, it really does kind of shoehorn you into the structural design. So as Suzanne was mentioning, kind of optimizing that base schedule with your unit layout is crucial. And it was something that we didn't have the opportunity to do on this project, again, because we wanted to be able to compare these apples to apples. So, being able to shrink or grow certain spaces in order to meet that kind of CLT span is going to be really crucial in determining early on, prior to just having like a bubble plan layout of units and saying, oh, well, we'll figure structure out later. There's so much optimization that can happen on the front end.
Great, thanks. Thanks, Ben.
Can I just add one last thing real quick? So one of the things with the bay size, if we could line up our columns, we would have greatly reduced our transfer. And a lot of the cost in carbon is in the transfer between the residential to your podium level. So I think that's the biggest thing for whether it's a mass timber or non-mass timber structure.
Great. Well, you teed that up well for Rob. And if the engineers can help design anything, then builders, I'm sure, can build anything. But Dave, what would you see as the cost savings potential if the design had been more optimized for mass timber from the start? And you're on mute here for you, just FYI.
Sorry about that. I think the best sort of practice in my mind goes to, making sure you're engaging early on, and don't be what a resource do you have with the sort of the mass timber manufacturers who sort of have this, some of them have a lot of this robust sort of engineering support in-house that can sort of help troubleshoot early, and like we would with like a curtain wall, package, maybe you're going to go into design assist and you're going to sort of, like we were just saying, optimize it through a design assist process and get it to a point where, someone brought up MEPs earlier, but like making sure your design is optimized and, working hand in hand with sort of the, with the MEP trades as well, to make sure the building is sort of coming together nicely. You're not going to find any sort of unexpected cost or changes later on that could be costly. So in general, I would just say, it's such a resource to have the mass timber community and the manufacturing community specifically, which are of great help, especially when you're engaging with them early and can kind of help steer a project to a successful budget. So I think that's, to me, I'd go right there. And then inherently, like any other process, I think there's probably going to be value engineering where you can find some savings elsewhere in your building. It's like you can get it close with the mass timber, but you can certainly look in other areas to see where you can find some improvements if you really want to make it work. So
yeah. Thanks, Dave. Great points about integrated design early and often, in the sequencing of the different trades and the different, as the sequence of constructability, you want to make sure that that's optimized, particularly with mass timber, is more challenging in certain ways than others. So making sure that that lines up and you get the schedule savings that you really want to get out of those projects. Well, I would just like to thank you again, all three of you, and Alexis, thank you for joining us as well. Such great projects. I really wish we would have had more time to get to all of the questions. I do want to note that folks, that we didn't get to your questions, please reach out to our panelists via LinkedIn or through their emails, or reach out to Olifant or Architecture 2030. We'll get you in touch with them to make sure that all of your questions are answered. I'd like to do a shout out to say that number one, that we have recorded this session. So if your colleagues missed it and you really want them to see it, it will be posted tomorrow on the Olifant website, olifant.org. And then we will also having next week the third and final session of this series, focused on mass timber accelerators, which are incentives for housing and economic development in cities. And we'll have presenters from the cities of Boston, Longmont, Colorado, I believe as well, Atlanta and New York. We don't see the Atlanta presenter here, but we did get them to join as well. So if you want to hear more about how these cities are advancing mass timber construction and incentivizing that in their cities, please join us for that session, which will also be recorded and included on the Olifant website. So from Architecture 2030, I would just like to thank again our panelists and thank Olifant and their funders for doing this work. And we look forward to continuing the conversation. Thank you.
Thank you.